So intuitively, when we drop something, like this guy is going to drop this green ball from a top of a roof, it's going to fall to the ground, and maybe we don't really see it, but it does pick up speed as it falls. Assuming that there's no necessarily air resistance, it's going to accelerate, go faster and faster and faster at a constant rate. Every second it falls, goodness, every second it falls, it's going to go faster, 9.8 meters per second. So the first second it falls, it will be falling at a velocity of 9.8 meters per second. In the second it falls, it will be falling now at a twice that. Instead of 9.8, it's 9.8 times 2, or 19.6 meters per second. In the third second, if you were able to capture how fast it's falling, it's now 3 times 9.8, or 29.4 meters per second. And then at 4 seconds, right before it kind of flattens out and hits the ground, it's falling at 4 times 9.8 meters per second, or 39.2 meters per second. Okay, and then over here on the far right is the distance it has fallen. Okay, based upon how it's accelerating. Pretty cool. So when we look at differences, we have an initial velocity here of 0, and we have a final velocity here of 39.2 meters per second. 0 meters per second and 39.2 meters per second. It's always the final state, the final velocity. From that we subtract the initial velocity. And just for all intents and purposes, we're just going to stick with initial velocities of 0, which is kind of nice. So to calculate then the average acceleration, we talked about this before. This is our delta change in velocity. This is our change in velocity divided by the time over which that change occurred, which the time over which the change occurred was 4 seconds. So I bet you're probably okay with that. Oops. If we were to go ahead then, I got my calculator here just for kicks. We can do that. The average acceleration is equal to the final velocity, which is 39.2 meters per second, minus the initial velocity, which is 0 meters per second, divided by the time interval over which that change occurred, the delta t, or time interval, and that was 4 seconds. Drum roll. Plug that into my calculator. Not so surprising. Sorry for the drama here. Not so surprising, if I divide 39.2 divided by 4, I do get 9.8. And let's go ahead and look at our units. Oh, my bad. Let me go ahead and what would units here be for what seconds? So unit-wise, then I've got meters per second in the numerator, and I've got another second in the denominator, so meters per second squared. So there you go. So we can, we're going to work a problem now, and we're going to come up with the final velocity given a certain time. And this actually is just rearranging the equation you saw on the previous slide, where we're solving for final velocity. But I'm going to kind of make it easier. Remember, I said that we're going to basically go from its beginning at rest. Okay, so if it's at rest, then the initial velocity is 0, and actually that becomes this. So that's kind of nice. And so let's just go ahead and say for your unit exam, I'm going to go ahead and kind of basically say you're dropping something at rest, and I want you to kind of consider that. If it's at rest, accelerating due to the force of gravity, your velocity keeps increasing, and then of course the time is kind of how that's all related. So let's work a problem And then I'm going to turn you loose with the video problem. So in this problem it says, and I guess you probably wouldn't have to make a drawing, but we'll go ahead and make a drawing. We're going to go ahead and here's my building, okay, and we're going to drop any object, and assuming that there's no air resistance, that object is going to go faster and faster, 9.8 meters per second faster every second it falls, okay? So the question here is, how fast will it be going? I'm going to let it go 5.2 seconds. So how fast is it going to be going? V sub f, what's the final velocity? And just eyeballing it, does this make sense? You know how sometimes they say, just look at a problem and does that make sense? But if it's going to go faster, 9.8, it's going to pick up speed, 9.8 meters per second for every second it falls. Well, if it's going to go 5.2 seconds, doesn't it seem like it's going to be going basically, how do I say this? I'm going to multiply these two numbers. Does that make sense? So, but let me go ahead and let's plug it into this. So remember, on your unit exam you're going to have formulas. So the final velocity is going to be equal to the acceleration due to gravity, that's that 9.8 meters per second squared, times the time. So I'm all about units here, so I'm going to go 9.8 meters per second squared. That's my acceleration, and my time of interest is 5.2 seconds. So the reason I'm all about units is I make sure that my units kind of cancel in my problem, so my seconds will cancel there. I've got seconds squared here, so only one of those seconds cancel, so I'm going to change that squared to a 1. When I plug that in my calculator, I get so my calculator displays a value of 50.96, and the units would be, remember those canceled, the units would be left meters per second. And we've talked a little bit about rounding in here, and I said kind of just, we're going to do a lot of multiplying, and then for sure if you're multiplying you can count digits. So I count 2 digits here, I count 2 digits here, and we can only then allow 2 digits in our answer. So kind of going from left to right, I'm going to keep the digit here in the tens place, keep the digit here in the ones place. And since that is a 9, I'm going to round up. So actually the best answer, ANS for answer, would be 51 meters per second is how fast it's going after 5.2 seconds. That's pretty fast. So now here's your video question. So I got kind of a similar deal. We're going to be dropping an object and from rest, which is kind of nice. And we know it's going to accelerate 9.8 meters per second for every second it falls. Now in the question here, here's my building, here's my object, make it green. And the question here is, so we're going to drop it and it's going to go faster and faster and faster. We want to know what will the time be, question mark time, when the final velocity is 120 meters per second. So again, if you kind of eyeball this, if you know it goes faster each time it goes 1 second, it picks up 9.8 meters per second. How fast in 10 seconds it would be going, what, 98 meters per second. So you know it's going to be more than 10 seconds, that sort of thing. But let's this time go back to the equation. So you're going to have this, you're going to have this on your test. So in this case, we know the final velocity, that's the 120 meters per second. We know A, that's the 9.8 meters per second squared, and we're trying to find T. And so I think I did an example of this before. If I was working this problem, what I would do right off the bat, if I want to get t by itself, I want to get rid of the a, so I'm going to divide this side by a. That will get rid of my a, and then I have to divide this side by a. Okay, so my a's cancel. I could rewrite this now, and I have t, which is what I'm after, is equal to the final velocity, which I know, 120 meters per second, divided by the acceleration due to gravity, that 9.8 meters per second squared. So in this form, I'm ready just to plug in. T is equal to 100, and I'm going to make sure I keep my units, 120 meters per second. That's how fast I want to be going. That's how fast it's going to accelerate is 9.8 meters per second, or meters per second squared. Now let's take a look at what cancels. Obviously, or maybe not so obviously, my meters cancel, and my seconds, those seconds cancel with one of these seconds, so I'm just going to change that to a 1. Now if I were to kind of look at what units I have left, I know this feels kind of weird, what units I have left is in the denominator. Don't have any units in the top, in the numerator, but in the bottom I have units of per second. And actually this can be simplified to, if I want to take this ratio that's in the bottom up, I have to flip it. So I can basically simplify this to flipping this, and it ends up in units of seconds is my point. So I'm going to go ahead on my calculator and plug in 120 divided by 9.8, and my calculator gives me something that has some digits. So I'm going to go calc, see how we want to round this, 12.2